Start with dominance. So let's say I'm just taking the example of the book. So we've got A, B, C, D, E, and you've got an A here. I'm just making something up, right? Let's say you've got a network, you've got a diagram like this. Now, let us say there is a sports competition that's running, and there are like 5 players, they are playing against each other, right? So an arrow from A to D tells me that A, when there was a match between A and D, A defeated D. When there was a match between B and A, B defeated A, and so on and so forth. If I ask you to look at it and tell me who was the most dominant player here, it'll boggle your mind, right? It's not that easy. A defeated B, and B defeated C, and C defeated A, so that means who's the strongest. And more players, more complexity. Correct? So what we do in this case is we create a matrix. We create a matrix. Let's create the one-step comms matrix, right? Let's create the first-step communication matrix. So I say, all right, I've got A, B, C, D, E, and I say A, B, C, D, and E. Let's say I create a matrix now. All right. So obviously your A to B, C, D, the leading diagonal will be 0 because they're not playing against each other. Correct? So if I say, okay, A was B defeated A, B defeated A, so 1. A defeated B? No. Right? And so on and so forth. So you fill this matrix up. You fill this matrix up, and let's say you've got a few 1s, a few 0s. I'm not copying this up, I'm just making something up for quick understanding. Let's say you fill this matrix up, right? Now what you do is you add the row counts. So you add the rows. This is 0 plus 0 plus 1 plus 1 plus 1, so 3. 1, 1, 1, 3. 1, 1, 1, 3. They have all 3. And this is 1. Let's say this was 2. Just made something up. And this is how it's going to be, right? And let's say this was a 4. Now, let's say you've got something like this. So this is called the first one-step comms. Now, let's say this matrix was a C matrix. Now, let's establish the two-step communication matrix. So you square it. So square this matrix, you will get another matrix. And then if you remember from the Eva Wong question, I said how many are total? So you added both of them. So once you add all of them, you will finally get one matrix, one big matrix. So in this case, that could be something like this: 0, 1, 1, 2, 0. So let's say this is A, B, C, D, E, A, B, C, D, E, and just putting some numbers. So it could be 1, 0, 2, 3, 0. 2, 0, 1, 3, 1, maybe 1, 0, 0, 0, 0, and let's say 0, 0, 1, 1, 0. Now, this is what you've got as C plus C squared. Now, Finally, you add the rows. This is what? 1 plus 1 plus 2 is 4. This is 3 plus 2, 5 plus 1 is 6. This is how much? 2 plus 3, 5 plus 1, 6 plus 1, 7. This is 1 and this is 2. So which out of the two, which out of these numbers is the greatest number? 7. 7 corresponds to player number C. So that means in this scenario, C was the most dominant player. And then you can rearrange. So C was the most dominant, then was B, and then was A, and then was E, and then was D. So that's the outcome of the competition. So we call this as dominance matrices. So the stuff that we just learned, the one-step comps and two-step comps, that's the practical application in a championship or in a big competition where a lot of players are playing against each other. So they use this to find who won overall. Right? Any dramas here so far? No? So if there wasn't any, let's quickly do a question. Let's do a very basic question. Let's do question number 1. Very basic question. Right. Question number 1, please. So row represents the winners and the column represents the losers. I want to hear the matrix first before you do anything else. Because if that's incorrect, then, and the arrows actually tells you whosoever that arrow is pointing to is the winner. So in here, A to B, between A and B, I'm just giving you an example again. Look, between A and B, if there's an arrow, so you go A to B. A to B is it's a 1 here. A to B is a 1. But B to A should be a 0.
So then A to A counts.
This will be a 0. I'll do a simpler diagram. A, B, C, D. Let's say one connection here. And this is how the arrows are flowing. Now, let's take an example here. A, B, C, D. So I say A, B, C, D. Another A, B, C, D. Alright? So I say A defeated B. So I go to A defeated B, a 1. And in the meantime, B was lost. Right? So B was lost to A. Yes? Similarly, any more connections to A? A to D. So A defeated D and D was lost to A. So that represents these two links. All good? Now what else? Let's go to B. So obviously A to A will be 0. And A to C, there is no connection, so I'll say 0. All good? Similarly, C to A is no connection, I say 0. Oh good, my first row is done. Let's go to B. B lost to A, it's a 0. B 1 C, so B to C is 1. B can't play with himself, it's a 0. And what about B to D? There is, so B to D. B was lost to D. No, so B was 1 to D, sorry. So B was lost because it's going up, so it is 0. Right? Let's go to C. C to A, there is no connection. C1 playing with B. C1 playing with B. Yes?
Didn't see this.
Sorry?
Didn't see this.
C1. Yes, C1, yes, C. I'm looking at this connection, right? C.
Yeah, C to B.
C to B
So it's
is a 0. Then C to C is a 0. And what was C to D? It is a. And the last one, D to D is a 0. And this is D to B is a 1. And D to C is a 1. Does that make sense? Now can you do question 1 please, part A. Can you construct the dominance matrix? So now what's the answer for, in this case, I'll just quickly write it. If you've done that or not, so Mitch, I'll give you another 30 seconds. If you've done the first one, just do the square to find the two-step commas, please, and then add them up, and then do this to give you the final dominance, if you're all good.
My class is dead, so I can't do it.
So Kaz is dead?
Yeah.
So your matrix row would look like 0, 1, 1, 0, 0, 0, 1, 0. That's the same matrix actually, right? Now can you do a square of this one, please? Let's say this is C. Can you just do a square and then you add C plus C square and give me the final answer. Who's the most dominant? Add the rows. Sorry?
D should be the most.
D should be the most dominant. Nanu, yes? What about you, Mitch?
What?
This was the matrix. Did you get this matrix?
Yeah.
You understand that?
Yeah.
That's precisely what the question is asking. That's the same matrix here.
Oh, okay.
Right? Same question. Then he says in the next part, you square it, establish a two-step commas link, you square this matrix. And then it says define dominance. Then you add the two matrices. And then you add the rows. And see which number is the highest. You will find that the last row has the maximum digit, which I think is what, 6. So dominance would be in the order of 3, 1, 0, and 6. That's how it's going to be. So row A will total up to 3, row B will total up to 1, row C will total up to 0, and row D will total up to 6. Alright? Cool. So there's nothing more in it, I tell you, right? If you want to try one more question, we can, I can give it to you. Can you do question number 4, please? Question number 4, exercise 10G. How many matches do we have in total?
10.
Sorry?
Should be 10.
10? Danu, how many matches it has in total? How will you do that?
Is it the order? The order?
Which order?
Oh,
What order?
No. How did you say 10? Added them? Added all the ones? Simple. In your first step comms link, if you add all your ones, that are the total number of links that you've got. That's the total number of matches. When you say how many matches, that means it's asking you to count the edges here. You add all the ones, you get the total count. So don't get confused in this trivial questions. Yep. Who's the most dominant out here? Part C.
Ben and Ellie.
Hmm?
Ben and Ellie.
What's the total of Ben?
3.
And what's the total of Ali?
3.
And how did we get there?